back up to that and hit enter. See what I mean?
Yeah.
Does that help make it easier? So, there we go, 2.9701, 2.9701. What if we made x, you know what's coming next? 0.999. What'd you get? 2.997?
Oh, yeah. Yeah.
Zero after that?
001 after that.
Okay, so 2.997 is okay?
Yeah.
Okay. So, here's my question for you. What is this getting closer and closer to? As x gets closer and closer to 1, what is the function getting closer and closer to?
3.
And so the limit is 3.
Oh.
And you could do it from the other side also. What happens if we did 1.01? 0.01, store x.
3.03.
So 3.03. What about 1.00? We can go 0.1, go 3 zeros. Do you feel comfortable with the limit being 3?
Yes.
Me too. Does that make sense?
Yes.
Okay. Yep.
So like make sure you have the right answer. Should you do it both ways?
You do need to do it both ways. We're going to show you a little bit why in a minute. So yeah, you do need to do it from below 1 and from above 1. Okay? So even though it doesn't exist at 1, as it approaches 1, the graph is going towards 3. Fair? Let's graph it. So to graph it, we would go x and 3 minus 1 divided by x minus 1. Yeah, on the chart there.
Oh.
Okay. But on the graph, we're just going to go x cubed minus 1 over x minus 1. And when we graph it, doesn't look like it's undefined at x equals 1, does it?
Is it?
And you know it is, right? And that's why sometimes these graphs are a little shaky. But here's what I want to do. I want to focus in on where x approaches 1. So I'm going to change the window. And I'm going to make my x min, we'll go 0 to 2. And we'll make our y's from 0 to 5. Okay? That'll focus in a little bit on what we're looking at. So, I mean, what's the main point that we're looking at here? And we know it. 1, 3 is the main point we're looking at. So let's just make sure that's covered.
It's a little gap.
Oh, look. Oh, look. See that little?
Hole.
It actually did the hole. I don't know if I've ever seen that. That's cool. Where is that?
1, 3.
So you can see this numerically, and you can see it graphically.
Yeah.
And that's what we want to be able to do. We want to be able to find limits numerically and graphically. And so we can do it we can do it these ways. All right? Okay. Questions so far? All right, the next one I want to do is the limit, let's see, I'm gonna blank out for a minute. The limit as x approaches 0 as x approaches 0 of x over the square root of x plus 1 minus 1. So typically when you get these limits, what's the first thing that you want to do? What would you guess? Plug it in. Yep, plug it in, because in our perfect world, when we plug it in, we'll get an answer and it'll be nice and easy and done. In this case, when we plug it in, we get 0. We get 0?
No.
What do we get? Error. We get 0 over 0, which as we know is 17. Thank you. Appreciate that. So when we plug in 0, we get undefined. It doesn't exist and things like that. So we got two ways to go from there. Option number 1 is to start throwing in all the numbers. Option number 2 is to throw it in a graph. Right? Well, we want to be able to do both. It's going to be very important that we do both. Okay? But I'm going to show you something with the numbers that hopefully will make life a little bit easier for you. So, anybody still need this stuff? So, back, okay. So on my calculator, I'm gonna go back to the y equals, and we're gonna clear this guy out, and we're gonna try to type this in. And obviously it becomes important to be able to type it in correctly. We're gonna go x divided by, and we better parenthesize this whole bottom, square root of x plus 1. And then I got a right arrow to get out of that radical, minus 1, close it. And I'm going to go back to Zoom standard just for a minute so we can take a look. And we get that. Fair? It's fair except for 1 point, right? Okay. So what we can do one of two things. We can start to zoom in on this and get an idea. But here's something else from the numerical standpoint. Okay? You see right there, table. Okay? So if we were to go to table right now, second table, we see this and we see that there's an error, which we knew, that was the whole idea, right? Okay? But we can change, okay, the table. If we hit the plus sign right now, because it says there at the bottom, press plus for table, so I press plus. And now this tells us, this says, what do we want to change, what do we want the x's to change by? And so remember how we had our little chart over here where we were changing by very small amounts? Well, let's do that here. Let's go by 0.1. What do you think about that? So we'll make our delta x, right? That's what this is, our delta x, we'll make it 0.1. And when we do that, you see that? And if I arrow up a little bit, so let's go to table 6. Let's make table storage 0.
The blue line skips over.
Good. Is that table 7? Good.
The little holes in the graphs are so adorable.
Oh, okay, yeah.
I'm so tired.
We don't care about that.
I
Because
never go
from
for
the
a
graph,
run because it's disgusting.
you saw the graph, right? It kind of stops.
I have a genuine
Because
belief
all of a
against
sudden what you're
running.
getting is
Karma
growth.
knows. These are such cute little
X
graphs.
less than negative
Aren't
one.
they?
Okay, sort of a negative number, which blows all of it.
Calculus isn't as hard as I thought it was going to be so far.
Make sense? Cool.
Not going to fight
All
with
right,
plastic.
so, what's the limit?
2.
Negative 2.
As we approach 0 from either side, what are we getting closer and closer to?
2.
2. And so that's why that is 2. If you wanted to change it to 0.01 instead, I go delta table 0.01. And now I go back to the table. And you can probably see even a little bit more there how it's getting closer and closer to 2. Is that fair? Okay, so now you have options, all right? As we're moving on, especially like Monday and that, we're gonna start to look at other ways to do it. But we also come across issues like this sometimes, and I have 10 minutes, beautiful. Okay. The limit as x approaches 0. Of the absolute value of x over x. Okay? All right. First of all, can we plug it in?
Yeah.
If we plug in the 0, what happens? 0 over 0, so no dice, right? So it's going to be similar to this, that it's going to have an error there. So again, we have two options. We can plug it in numerically, or we can look at it graphically. I would like to look at this graphically first, okay? So do you know how to do this? I believe it's under math. And then over to
Where's this?
NUM.
Yeah.
Where's
And
math?
No.
ABS is absolute value.
It's on the off button.
And you can see that there. Absolute value of x. Make sure you right arrow to get out of there.
No.
And divided by x.
1.
And remember, let's go back, make sure that your window goes
Ah.
back to what it was
What the-
before. So zoom 6. And that's weird, isn't it?
It's broken.
Why is that weird?
It just
Skips.
It skips. So if we started plugging in numbers like 0.3 and 0.2 and 0.1 and 0.01 and 0.001, what would it be getting closer and closer to? No. If I plugged in 0.3 and 0.2 and 0.1 and 0.01 and 0.001, what would it be getting closer to?
0.
I don't think so.
It just stay at 1.
I think it'd be getting closer to 1, right? Because isn't this, see how this is going? I mean, what's the line up here?
X or Y.
That's y equals 1, right? This is y equals 1?
Yeah.
So as we get closer and closer to 0 from the positive side, 0.3, 0.2, 0.1, 0.01, 0.001, it looks like our limit is going to be
What?
1. But if we did it from the other side, and we were doing negative 0.3 and negative 0.2 and negative 0.1 and negative 0.001, etc., what are we getting? What is it looking like the limit is there?
-1.
Negative 1. Does that make sense? So graphically from here, we're getting closer to 1. Graphically from here, we're getting closer to -1. And because of that, because it's different on the two sides, the limit does not exist. If what you're going to is different from the left than it is from the right, the limit does not exist. Which is why whoever asked the question before, that said, do we need to do it from both, or should we do it from both sides? Was that you? Somebody asked, should we do it from both sides? Yep. Because we need to do it from both sides so that we can make sure that we're going the same direction, or we're going to the same place from both sides. Does that make sense? Okay. So if it goes two different places from the left and from the right, then the limit does not exist. Okay? All right. Next. Yes.
Oh, meaning the square.
Huh?
I just saw that up there.
Yep.
I remember that.
And that. All right, here is the next one. F of x equals, here's our function. Our function is piecewise. F of x is 3 when x is not equal to 2. But f of x is negative 6 when x is equal to 2. So the question is, what is the limit? Oh, the limit as x approaches 2 of f of x. Now, this is important. The limit is, remember what we said, how it's phrased. Wow, that's a terrible arrow. That's better. This says the limit as x approaches 2. Now, typically when we have functions, you know, if we can plug that number in, it's usually because it's continuous the whole time, and if it's continuous the whole time, then the limit is just f of 2 in this case. But what happens here? Okay, do you guys know what this graph looks like? So, right, f of x equals 3.
And there's only 2.
Except right there. And that point is down there. Does that make sense?
Yeah.
When x equals 2, f of x equals negative 6. But when x is not equal to, when x is anything else, f of x equals 3. So, the limit, and this is important, I already said that, is what happens as we approach 2. So, what is it as we approach 2?
3.
It is 3. As we approach 2 from this side, we're at 3. As we approach 2 from this side, we're at 3. The fact that f of x at 2 is down here is actually irrelevant. Because it's what happens as we are approaching 2. Does that make sense? Is there a question? Yep. What we were looking for is what happens as x approaches 2. So we're not actually asking what happens when x is 2. We're asking what happens as x approaches 2. And so as x approaches 2, we're at 3. As x approaches 2, we're at 3. So it's approaching the same thing from both sides, and that's why our answer is 3. What f of 2 actually is actually irrelevant. It's what are we approaching. Now this is a rare case, this won't happen a lot. But if it's approaching, and then at that number it's somewhere else, where it is at the somewhere else doesn't matter.
So we don't use the point because it's not like a line.
It's not continuous.
Yeah.
Yeah. If it's continuous, then we have no problems. We just plug in the number and we're fine. But if it's not continuous, then we need to deal with these different things. Questions? All right. that gets us through that stuff. We're not doing delta epsilon. So you can do most of. What I would like to do on Monday is I would like to wrap up one or two things from this section and then jump into 1-3, and then that'll get us caught up that day that I was out.